So thanks, Tim, for that. As I told you guys, it was really dense. There's still a lot more questions, but we'll put the questions in the Slack channel with the answers so we can get sure that everything is there for you. Before we go to the next session, I do want to remind everybody, meet the experts. Please, if you have any questions, go into the Slack channel, check out the Meet the Experts page so you can see who's available. We'll also pop that in again so you can see which developer is available to answer your very specific questions about InfluxDB or Telegraph. The other thing is I was actually kind of poking around in Twitterland, and one of our friends, Bastian, is actually having a kind of a watch party at one of their hack spaces, and he sent a picture of that and a bunch of his friends. So that was kind of cool to see. I'm always keen to know, like, if you're comfy on a couch or you're behind a desk like me, where you're, hanging out watching InfluxDays. So send those photos in. It's pretty cool to kind of get that feeling that we are really all together and not just staring at another monitor. So we will have a break at 12:15, but before that, we've got one more talk from our friend Bhagvan from Whitecoats. And we do only have 30 minutes for this session, so I apologize if we get a lot of questions and we don't get them all answered, similar to what happened with Tim's talk. What we will do is we will post those questions in the Slack channel and make sure we get them answered that way. But who knows, maybe Bhagvan will be able to talk really fast, get through all his content and the questions. But we'll be maybe monitoring that in the event that we run up against the clock, because I do want to make sure that we reserve the full 30 minutes for you guys to be able to take a break, as well as chat with the experts, get your questions answered. All right, so with that, I am going to pass the baton over to Bhagvan. Bhagvan, are you ready?
Yeah, I'm ready. Can you hear me? Yeah, can you hear me, Kat? Emily? Yeah. Hi, everybody. I'm Bhagwan Kommadi, a Director of Product Engineering working for Value Momentum. It's great to be on Influx Days. So today I'm going to talk about DevOps-based progressive delivery for telehealth platform. I hope everybody is able to see the screen, the first slide. So today's agenda, we are going to look at the mind map for DevOps, what telehealth solution we are building over here in Value Momentum for white coats, a little bit on the architecture front, and also AI, the deep learning solution, and how what is the implementation, and all the and then what's next, and the sneak preview of upcoming features. So as you all know, DevOps is based on three key principles or three pillars, right? If you want to visualize agility, quality, and flexibility. So let's start off with the mind map. Right? And if you see on the right hand side, right, you have the no code platforms, low code platforms. Right, on the left hand side, you see the DevOps, healthcare, cloud, IDE. So you have containers like Dockers, Kubernetes, right, where you have different what do you call within the containers. You have different applications, right? You have orchestration, right, initializing, configuring applications. And you have version control systems, right, where you maintain the source code, and you have like JIT, and you have testing environment, automation, and CI/CD tools like Jenkins. Right? You have pipelines configured to pull them from JIT or GitLab, right? And the code gets built, and you have on the cloud environments, right? Connection from Jenkins to running scripts through logging into AWS CLI using scripts, SSH, and installing applications. Right? So And at the bottom, a little bit on the domain front, where we're going to talk about healthcare, the health insurance, life insurance, digital health. So the intersection is part is very interesting, and in this talk we are not going to focus too much, but how the DevOps is going to interrelate or correlate with the no-code platforms. Right, in no-code platforms, you have customizations, you have metadata, licensing, and subscription, and tech stack, and you have low-code platforms which are generators. So this slide you can have it in the mind as a map whenever we refer, right, the left-hand side, which will be the key area which we are going to focus in this particular talk. And also, very importantly, monitoring tools like Nagios, right? And the on AWS, you have Cloud Formation, Cloud Watch, right? Cloud Watch, Cloud Formation. Similarly, on different cloud environments, you have monitoring tools. Now, let's take a step back from the mind map and start looking at telehealth solution. Right? As we start off this telehealth way before the COVID pandemic, right? We never thought telehealth will become popular. So it was a simple idea based on WebRTC based solution, right? Having historical data, neural network, and algorithms which were used. So we started off building this particular telehealth to have video consulting, chat consulting, audio consulting, right, and also scheduling appointments. And it can be in person, it can be offline, it can be online, right? It can be on the mobile consultation. So we thought of a very simple architecture to start with, but how it evolved was very very interesting. If you look at after the pandemic, even now people want a telehealth app, right? And so we have around 4,000 clinics, right, who are implementing telehealth application, having their own mobile app, right, is deployed on the Play Store, right? And each of those clinics and doctors are conducting telehealth consultations. So the telehealth app is now like almost like a necessity at every home in India, in Asia, right? Like if you like we used to have like a telephone, right, or a cable. It almost like a utility, right? So similarly, we're going to have a telehealth app from a clinic or a doctor. So that's the background of the on the telehealth solution. Now, within the telehealth, you have patients. Now, let's look at the patient journey. You visualize yourself entering into a hospital, right? You have a concierge or reception where you want to take an appointment with a doctor. But once you take an appointment, you get a message saying that you have an appointment reminder, right? On the same day or the same in the same place, or you go out, you get a SMS message, right? And also you track the schedule, you intimate the delays of the doctor, right? Within the hospital, the receptionist will intimate to the patient. You can also manage appointments within the telehealth application, where you're checking for follow-ups, right? And after appointment, what happens? The post appointment engagement, sending them alerts to take the tests, sending in alerts to follow up, right? Or if it's like a seasonal disease, right? Send an alert saying that last time when there was fall season, right? You have the pollen allergy. Similarly, the fall season is going to come, and this is the high pollen month or week, right? Some alerts like that. So, looking at the patient journey, right? What patients want and what is the doctor's view. Every patient wants to know. Doctor needs to know him, right? Care about him, and also the doctor needs to be competent. Right? He needs to improve cure and prevent the problem. And from a doctor point of view, it's not just what you call caring and knowing, but also what has happened before, right? Before even coming into his clinic, what was his historical data, right? What was his patient? What is the patient's parents' history, father history, mother history, health history, right? The whole genetic thing, and what I have seen before, right? As a doctor, what he has seen with a similar kind of patients. So demography, words, general appearance, sounds, physical signs, smell, touch, feel, X-ray images, fluids, and tissues. Now, moving on from the patients and doctors, let's look at the AI part, right? The voice assistants, which are playing very important role. Right? And you have voice assistant, persona, intents, metrics, right? Right? You have UI, you have analytics, context management, integration. Right? For voice assistant, you select the personality traits, psychographic traits, accent. Right? For intent, like utter recognition, accuracy. The metrics you track, benchmark, and improve. How accurate was the answer to a question? Was there any feedback saying that the chatbot was unable to give answers for the patients for related to healthcare or appointments? Let's say the appointments were taken to the voice assistant. Similarly, the voice assistant also help doctors to take notes. Was the voice assistant really helpful for the doctor to take notes? So on the knowledge base front, let's look at the process flow. Right. So the historical data related to the diseases information, right? What kind of diseases? What are the different data sources like Orphanet, John Hopkins, WHO, Nod? It updates keep coming. Late new diseases, rare diseases, artifacts keep getting added to a specific disease. Right? Now, as a knowledge domain expert, you have a top-down view looking at what are the rare diseases, what are the common diseases, what are the top five diseases which are affecting most of the patients in the world. Right? From a bottom-up point of view, let's say you want to build a knowledge base, need to have a registry. You need to know the data sources. You need to know what artifacts you need to recover from the knowledge base. So why do we require the knowledge base? Right? Like immediate question you have in mind. We talked about patients, we talked about doctors, and we talked about chatbots. Right? So why do we need the knowledge base? Knowledge base provides information, provides a history, it provides the information about the diseases. Right? It's not just a human doctor. The AI needs the knowledge base, right, to query and see what are the symptoms and to validate and check. So we use NLP, and also we have API to work with the NLP in terms of queries, querying the knowledge base, querying it for the disease information, and accessing this information from web, mobile, and desktop. So an knowledge-based architecture has a simple layered architecture like visualization, service layer, data access layer, and we have knowledge-based manager using Axios, Cheerios, and Node, and you have search manager, and you have knowledge updates which keep going to disease knowledge and disease registry. We looked at the voice assistants. The digital assistants and the video bots are used for taking clinical notes, retrieving cases. The video bots are used for creating consultation appointments. Right? Digital assistants are used for updating prescriptions. So let's look at the architectural components. You have mobile and web. You have the tech stack, which consists of Laravel, PHP, polyglot microservices like Java, Python, PHP, and Laravel. Your MySQL and MongoDB. MongoDB is a NoSQL database. DevOps tool is Jenkins. Now, moving on to the DevOps front, what are the foundational tools and infrastructure? So we have the bug tracking system, defect tracking system, monitoring systems, monitoring the infrastructure, monitoring the cloud, monitoring the databases, right? And also the configuration management. What kind of configurations are required to initialize the OS patching, the CI/CD pipelines which are connecting to GitLab or Git or any other source code or version system, containers like Docker, Kubernetes, source control systems, and collaboration infrastructure. Now, in any company or any development center, right? You have engineering teams. They start off right at a very low level of DevOps, right? Where the simple way to say is that they have the what you call deployment frequency happening monthly, right? And lead time is like between week or to 6 months. The mid-level DevOps maturity is like you have the deployment frequency happening between daily and weekly, right? And the lead time less than a week. Then you have the high maturity for DevOps, right, where deployment happens on demand, right? Less than an hour, lead time is less than an hour, or metric with still value. You have the change failure rate less than 5%. So back in old days, you remember there was continuous integration tool called cruise control. Right? I remember when I was a developer, there was a red bulb at the behind in the development center, right in the hall. And whenever the build fails, right, there's a connection between the cruise control to that electric bulb, right? Every day, if the electric bulb flashes, all the developers have to run and then start checking what happened to the build, where things went wrong. Right? So whenever I see this slide, right, especially the high DevOps maturity where lead time is less than an hour, I remember way back in Denver, right, we were sitting in a hall and there's a red bulb behind and flashing, and everybody running around to find who made the mistake and how to fix it. So that's on a lighter note. Now let's see the challenges, how to move from low to mid and high, and what are the challenges when you are at the lower maturity levels. Right? There's the resistance to change, the legacy architecture, shortage of skills, lack of automation, right? Unclear objectives. In the mid level, still there is a resistant change, there is a legacy architecture, but the objectives are very clear, right? What to do. There are sprints and releases, and when how the whole concept of continuous integration, continuous development is there. Right? At the high level of maturity, right, there is no resistance. Right? And still, it might be a legacy architecture, there may be less shortage of skills. Now, you all are familiar about this flow of change, but I just want to capture right how the information flows from the business domain or from the business team, right? Where you have different streams, you have a platform team, you have a stream-aligned team, you have a complex subsystem team, right? And also you have a stream-aligned team. And there's an enabling team which is merging all the changes, and there's a flow of change which is coming from the business team, which is related to business domain, and you have collaboration and the external services, and they are facilitating and then combining, merging and deploying them on the cloud. Now let's jump in directly, right? Till now we have been talking about conceptually, right, about DevOps maturity levels, what are the challenges, but specific to Jenkins, right, what are the key features? Right, authorization, administration, analytics, scalability, availability, distributed teams, and container support. And primarily, this famous pyramid, right? You have quality, time, and cost. In between is the product. Right? That's where the balance is between quality and time. You know, the quality is very, very high, right? There's this problem with the time, and then you spend too much of time. The cost is very high. You need to have find a balance in between. That's when you have a great product. Let's look at the DevOps workflow, right? And we keep talking about pipelines, starting from the version control system like GitLab or GitHub. Right? There's a version control system you want to continuously integrate, continuously deliver, and you want to continuously deploy. But what happens in between these two steps? Right? You have code checkout, you have build the code, you test the code, you stage the build, you release the build, and you deploy the build. The other interesting part which we are talking about is the progressive delivery. It's not just building it from the Git repo. The Jenkins trigger, right, builds the process and then update what called deploys on the AWS cloud, and you have the live web app. Right? Similarly, we want to do this for the mobile apps, right, where you have Jenkins build process. It's sending updates to Google Play Store and Apple App Store. Now, what are the benefits of using Jenkins? Clearly, right, you can have the advantage of quality, like you can have end-to-end, like that, like we're talking about the pyramid of balance. Similarly, you have the test pyramid, which looks at unit tests, functional tests, integration tests, and end-to-end, right? So the benefits are like autonomous teams, a simple setup, delivers release in time, faster delivery, higher productivity, software productivity, predictability, sorry, predictable in terms of number of defects coming in, number of issues, business sustainability, autonomous teams, and audit trails. So, what is Jenkins architecture? It's based on agents, right? If you have Jenkins server, you can have Jenkins agent working on different build procedures on different environments. And here we use GitLab. DevOps best practices. Right? So many people ask this question, right? What are the best practices we need to follow to make this DevOps really work, whether I'm at low or mid or high? So the key concept is automating the software delivery, treating release orchestration as a business imperative, adopting best of breed solutions, but doing so judiciously, right? Practicing value stream thinking, using feature flags for safer, faster software delivery. So if you recap and remember in the old days, right, we used to have flags saying this flag is on, right? And I'm going to debug, right? Flag is on, I'm going to log, and monitoring is on, right? We used to have flags. Whenever we wanted to things to run faster, we need to switch off those flags. Similarly, the feature flags are specific to not just performance or logging or not for non-functional. You can have function-related flags, right? Saying that I'm going to use an algorithm which is very basic to start with. I don't want the complicated algorithms to run or the complex algorithms. So you can have flags for the business logicals. Similarly, this module is on, this module is off. So those are the feature flags which really help in terms of safer and faster software delivery. And also you can switch out the functionality wherever things are not working fine. And you can switch out the functionality. Now time for demo. So I just wait for demo to be on the
Yeah,
screen.
this is a demo for Jenkins. Logging in as admin. We created this test project. Configure this test project. Okay, GitHub directory. So the repository is project test. It's a Selenium test. Configure this to poll for every 1 minute. So there are no changes as of now. Last build there was intent. So I added a small test for Flask. There are some compilation errors. So that was a different Flask example. So let's run. Let me run the customer data.py. It already exists. So, customer.py. So now it won't be able to. So we need to trigger the change. So just go in and clean up the code. and continue the changes. Come back. It's 2:31. So now we found the we started creating the bill. You see the comments clean the code from the JIT. The compilation code is completed. It's going to run this suit. The previous Flask example was a simple page with running Flask. Now we should detect the customer. So now it will add customer. So it runs the test case. There are no failures here. It's successful. Similarly, you can configure the Maven or Gradle projects for the mobile app delivery all the way to.
So that was the demo, right, where you saw Jenkins in action, and where you had the application on the right hand side, which is a Python application, and the customer data which was filled up by the Selenium tests. Right? The JIT repository had the Selenium tests, and the Selenium tests will run through the Maven. And so that was the demo, a very small demo. And similarly, we can extend that what you call Jenkins integration to do unit tests or functional tests, not just the web applications, but also on the mobile apps, but using different automation tools. I just want to spend 2 or 3 minutes on the deep learning solution. In the interest of time, I'm going to skip some of the slides which are obvious. So CNN, right, convolution neural network consisting of various layers, input layer, multiple hidden layers, and output layer. I think you're all familiar. So in the how the image recognition is done, we have the pixels, image pixels, which are determined by pixel value, color depth, grayscale intensity, right? And you have typical CNN having layers, fully collected, pooling, convolution, and rectified linear unit is being used for CNN. So what are the different CNN models? I think you're all familiar. VGG 16, 19, ResNet 50, Inception version 3, DenseNet, NASNet, and MobileNet version V2. These are all Keras pre-trained. So in this telehealth platform, we were analyzing the X-rays for lung disease analysis. Right, the key attributes or features we are looking for patients from the patients was from gender, X-ray position, and also for various diseases. And we have the test or the training data like atelectasis 192, and total result we had around 5,606 X-rays which were analyzed. So in the long-distance deep learning solution, right, in CNN, we had the flip, scale, shift, and rotate and salt pepper analysis. We had the training, testing, validation done, right, and we identified the X-rays as normal infection by virus, infection by bacteria, and we also gathered statistics or metrics, right, from the true positive, false positive analysis. So we have identified precision as true positive by actual results, and recall as true positive by predicted results, and accuracy is a true positive plus true negative by total. And these are the results. If you look at the precision, is 73%, 0.73, and recall is 0.07. F score is 0.26. So this should be straightforward, but we used 7 by 7 convolution 16, 5 by 5 convolution 32 max polling, 5 by 5 convolution rectangular linear unit max polling, flattening dense rectangular unit, and the output layer. And this is the complete data set. Now let's get to the implementation. We were talking about 4,000 clinics, right, and the specific details. Right, we had around 3 lakh doctors, location 3,000, right, and we had both like a social community app for doctors to interact and discuss, and we have practice place for practice management. We have onboarded doctors, who were around 50,000 for network app. Number of specialties 125. In the practice plus product, we had clinic plus, staff plus, and patient plus. So many customers or in many conferences, people have this question. They're going, great, Telehealth, the platform is great, progressive delivery, app delivery, web app delivery, mobile app delivery is great, but what's next? So next level in DevOps, right, we're looking for relation of programming paradigms to continuous deployment, relation of database normalization to deployment, complexity of DevOps, overall effect of CD on application quality, prevalence of version control, right, count of manual interventions required from dev to production, and also site reliability engineering, not just DevOps. So moving from DevOps, we want to get on to data ops, DevSecOps, AI ops, and ML ops. Today morning, I was reading about FinOps, right? Compliance ops, not just data ops, but financial optimization, right? FinOps, compliance ops, various other new acronyms coming in, right? Where they're focusing on data operations and security and development. And on each level, you have various tools. In the interest of time, I'm going to skip, and you're getting new roles for the future like vendor engineering, product engineering, socio-technical systems engineering, and portfolio management. And if you look at agile safe methodology and CAMR, where you have increased frequency, quality, and security of product innovation, acceleration of solution to time market, improved solution quality, right, and reduced severity and frequency of failures, right, the scalable agile, not just a simple agile process. Regarding the site reliability engineering, the focus, if you look at it, DevOps focus on delivery, release automation, infrastructure as a code, and config management. Site reliability engineering focus on reliability, performance, monitoring, and efficiency improvement on the infrastructure front. The intersection, if you look at it, it focus on waste reduction, automation, scale, and systematic perspective. And in terms of the telehealth platform, right, we are going to evolve that to genomic application, personal medicine, evidence-based medicine, predictive toxicology, right? And we have data, evidence, action, guidance. So, any questions? So, thank you all for giving me the opportunity to talk on Influx Days. It's great talking to the audience on Influx Days.
Cool. Thank you very much. If you do have any questions for Bhagwan, as I mentioned before his talk, let's pop those into the Slack channel.